Welcome to Civil Engineering Academy YouTube channel. In this video, we are going to learn some of the basic concepts related to engineering mechanics subject as per the VTU syllabus of the subject PCIVC 103 or PCIVC 203. The first basic concept that comes across this particular engineering mechanics is force and the characteristics of the force. What is generally force known as? Generally, the force is nothing but it is an external agency, very important word. It is an external agency which tends to change the state of the body, which tends to change the state of the object or particle. That means if there is an object which is at state of rest, and when you are going to apply the object with certain force, the object will be disturbed with respect to its state. The rest object start moving, or the object which is moving by the application of the force can attain certain increase in velocity. That's why these two words are very important while you are defining the force. A force is an external agency which tends to change the state of the object or particle. What is the SI unit of force? The SI unit is given by Newton and it is indicated by capital N. Very important. It is indicated by capital N. There is one conversion related to the force, that is, the force can also be indicated by the word kilonewton. It can also be represented where K is indicated as small letter and N is indicated in capital letter. That is, what is the relation between kilonewton and Newton is 1 kilonewton is equal to 1000 Newton. This conversion is very important. So, a force is an external agency which tends to change the state of the object or particle. And also, what is the SI unit of force is Newton. It is indicated by capital N. The force is also represented in the SI unit kilonewton, where K is in small and N is in capital when you are indicating it. And the final conversion, 1 kilonewton is equal to 1000 Newton. The next important topic is the characteristics of the force. We had just learned about the definition of the force. Now we are going to discuss about the four major characteristics of force. Number one, the first characteristics, it is the magnitude. Number two, the second characteristic of force is direction. And number three, the third characteristics is line of action. And number four, the fourth characteristics is point of application. Very important, one of the most important theoretical concept. What is force and what are its characteristics? The characteristics of force is magnitude, direction, line of action and point of application. I will just try to write down a diagram and then we'll explain each characteristics, that is magnitude, direction, line of action and point of application. What is magnitude? We know force is a vector quantity. What is a vector quantity? One which has got direction and also magnitude. Here if you observe this force which is represented in the diagram, this length L is indicated as the magnitude. That is, the length of the vector is known as magnitude. Now if you observe this particular, arrow, it is indicating the direction of the force. What is line of action? For example, if this is the force, the path traced by the force is known as line of action, or it is the line along which the force is going to act. And finally, what is point of application? The point at which the force is going to be act is known as point of application. So the four characteristics of the force are magnitude, direction, line of action, and point of application. These are the four major characteristics of a force. The next theoretical concept is the classification of force system. Classification of force system. What are the different classification of force system? Before going to the classification, what is this word known as force system is called? A force system is nothing but if there are more than two or more forces are acting on a body, it is known as force system. Very important. Now, there are three classification of the force system. Number 1, coplanar force system, non-coplanar force system, and collinear force system. These are the three major categories of forces. What is the meaning of coplanar? If all the forces are acting on the same plane, then it is called as coplanar. If all the forces are acting on different planes, then it is called as non-coplanar. These two diagrams indicate the difference between a coplanar force system and a non-coplanar force system. There is further classification. We will take up each category. That is, number 1, coplanar force system. Each force system has got subcategory. Under coplanar force system, the first one is coplanar concurrent. The second category, coplanar non-concurrent. And the third category, coplanar parallel force system. So these are the three different categories, starting with the second one is coplanar. The third one is the coplanar parallel system. Under coplanar parallel, we have got two subcategories. One is like and the other one is unlike. So each category has to be classified with a perfect diagram. So we have already spoken about what is coplanar force system. That is, coplanar is nothing but all the forces are acting on the same plane. Then what is the meaning of coplanar concurrent? Coplanar concurrent is nothing but, please observe the diagram very carefully. All the forces are acting on the same plane and all the forces are set to pass through a common point. Please observe here. F1, F2, F3, the origin of all the forces are the same. That is what coplanar concurrent is all about. Then what is coplanar non-concurrent? We already know coplanar is nothing but all the forces are acting on the same plane. But the origin of all the forces, there is no common point of origin for all these forces. So it is coplanar non-concurrent. So what is coplanar parallel? all the forces are acting on the same plane and all are parallel to each other. All the forces are parallel to each other. Now I said under the category of coplanar parallel we have two categories. One is like and the other one is unlike. You please observe the change in the diagram with respect to like and unlike. The arrowhead of all the forces are in the same direction. In the second category, the arrowhead are in different direction. So, if all the forces are parallel and if are acting on the same direction, it is known as coplanar parallel force system under like system. If all the forces are acting on the same plane and are parallel and are acting in the different direction, then it is called as coplanar parallel unlike force system. So this is the classification of coplanar force system. The second major classification, non-coplanar force system. Under this, once again, non-coplanar concurrent, non-coplanar concurrent, non-coplanar non-concurrent, non-coplanar non-concurrent, and non-coplanar parallel force system. So these are the three subcategories. What is the diagram for non-coplanar? We are going to just write on a cuboid and we are going to represent. What is the meaning of non-coplanar force system? Concurrent. All the forces are acting in the different planes but have a common origin. Non-coplanar concurrent. What about non-coplanar non-concurrent? All the forces are acting on different planes and does not have a common origin. What about non-coplanar parallel force system? All the forces are acting on different planes and parallel to each other. There is no like and unlike as we saw in the coplanar force system. So non-coplanar concurrent, all the forces are acting on the different planes and has got a common origin is known as non-coplanar concurrent. What about non-coplanar non-concurrent? All the forces are acting in the different planes and does not have a common origin. What about parallel? All the forces are acting in different planes and are parallel to each other. Very important. The last classification, the third classification, collinear force system. It can also be subdivided as non-collinear force system. This is the diagram for collinear force system and this is the diagram for non-collinear force system. We have got two different types of diagrams. What is the definition actually? The line of action of all these forces are coinciding. If this is F1, F2, F3, we are having common line of action. But if I take these two diagrams, F1, F2, F3, F4, or in the second diagram, F1, F2, F3, the line of action of all these forces are not coinciding. That's why it is called non-collinear. So if the line of action of all the forces are coinciding, we call it as a collinear force system. If the line of action of the forces are not coinciding, then we call it as a non-collinear force system. So under the classification of the force system, there are three major categories: coplanar force system, non-coplanar force system, collinear. Under coplanar you have got coplanar concurrent, coplanar non-concurrent, coplanar parallel force system. Under the coplanar parallel force system you have got unlike and like system. Under non-coplanar force system you have got non-coplanar concurrent, non-coplanar non-concurrent and non-coplanar parallel force system. Under the category of collinear you have got two, collinear and non-collinear. So this is the answer with respect to the what is force system and what is the classification of force system. The next one, there are three major principles related to forces. The first one is principle of transmissibility. The second one is principle of superposition of forces, and the third one is principle of physical independence of force. So these are the three major principles related to the force. What is principle of transmissibility? We are going to write down an object, and please observe the diagram carefully. There is force F1 which is acting at point A, and there is force F1 which is acting at point B. The magnitude of the force is same. Before getting into the theoretical concept, let us give you an example of numerical. This is point A and this is point B. Here the magnitude of the force is 10 Newton. Here the magnitude of force is 10 Newton. This is the line of action and this is the line of action. Here, for example, if a force is applied with respect to this object at point A, let us assume the object moves by 1 meter distance. 1 meter distance. Here, the force is of same magnitude and this force is applied at a different point B, but it is applied along the same line of action, then the effect will be same. That is, it is going to travel to a distance of 1 meter. That means when the same force is applied at two different points and those 2 points are along the same line of action, observe here, it is along the same line of action, the point of application is going to change, then the effect produced by those force will be same. That is, the distance travelled is 1 meter and the distance travelled is 1 meter. For example, here the force is applied at A and here the force is applied at B. But if you can see, the line of action is not the same, then the effect is not going to be the same. So what is the definition of transmissibility? The principle of transmissibility states that a force can be transmitted from one point to other, that is, here it is transmitted from point A to point B along the same line of action, very important, along the same line of action. If the force is transmitted along the same line of action, the effect produced by the force, remains constant. Very, very important. If the line of action is disturbed, then whether the effect remains same? No, the effect does not remains the same. It might change. Here the distance might be 1 meter. Here it might be greater than 1 meter or less than 1 meter. So the change, the transmission of the force should be along the same line of action. That is what the principle of transmissibility says. The second one, principle of superposition. Principle of superposition of forces. Now let us write down the diagram here. The force A, force B, and finally we are having a combined force A plus B. Let us assume force A is of magnitude 10 Newton, force B is of magnitude 10 Newton. When this object is applied with the force of 10 Newton, the object moves by a distance of 2 meters. When the same object is applied with a force of 20 Newton, the object is moved by 4 meters. Here 10 Newton plus 20 Newton, the total is around 30 Newton. Then what will be the distance travelled by this object? 2 plus 4 is equal to 6 meters. That means when you are applying individually two forces, whatever the effect that is produced by the two forces separately, and when the forces are combined, the net effect will be the same. Please observe here. An object was applied with the force 10 Newton, it travelled 2 meters. The same object which applied was 20 Newton, the object transferred for 4 meters. When the forces both were combined, the effect that you are going to get is the same. Then what is the definition of principle of superposition of forces? This principle states that that the net effect of a system of forces, please observe the word net effect, very important. The net effect produced by the forces on the body is same as that of the combined effect, is same as that of the combined effect. So when was individually applied, it traveled 2 meter and 4 meter. When the two forces are combined, it is traveling at a distance of 6 meter. The last one, the principle of physical independence. Principle of physical independence of forces. That means there is number of forces acting on the object. Let us assume the object is having 10 Newton, 20 Newton and 30 Newton. Now, whatever the magnitude of the force be, it has got its same effect. The other forces are not affecting the effect of this force 10 Newton. For example, 10 Newton might move the object by 1 meter, 20 Newton might move the object by 2 meter, 30 Newton object might move it by 3 meter. Now what does this physical independence says? Each force is not affected by the action of the other force. That is what principle of physical independence states that. So, the principle states that the action of a force on a body is not affected by the action of, very important, action, the word action of other forces. Action of other forces. So this is what the different principles are all about. We started with principle of transmissibility. It states that a force can be transmitted from one point to another point along the same line of action such that the effect produced by the force on a body remains unchanged. We moved on to the principle of superposition of forces. It states that the net effect of a system of forces on a body is same as that of the combined effects of individual forces on the body. And the last one is, it states that the physical independence of forces states that